Bismillahirrahmanirrahim. Dear viewers, today we will solve few issues in Staad. So let's start. What we will see in this tutorial. Number 1, possible problem while including dead load and live load in seismic weight. Number 2, error. Only one UBC case can be solved in a tension compression analysis. Number 3, warning. If this UBC IBC analysis has tension or compression or repeat load or reanalysis or select optimize, then each UBC IBC case should be followed by perform analysis and change. Number 4, warning. In stability at joint, here will be number and direction equal to here will be the direction or moment about any axis. Okay. Then warning, zero stiffness in direction, here will be the direction number. So these issues we will solve in this tutorial, and we will also discuss about few basic of these issues. So come to number 1, possible problem while including dead load and live load in seismic weight. When we copy dead load and live load as member weight under the seismic definition, then there may happen unit problem or the distance problem. We will see that with solution. Let's see here. Here we can see we have provided dead load on specific members, live load in this way. Now we want to include this dead load and live load in seismic definition. Here we can see in previous tutorial we have seen I have added self weight only to show the issue about the serial of seismic load cases. Now we will add dead load and live load in our seismic definition as member weight. For dead load we have to add 100% of dead load. For live load we have to add 25% of live load as member weight in seismic definition. We will go to Staad editor. Here we can see define IBC 2006. That means here we have defined our seismic definition, added self weight only. Now we want to add 100% of dead load plus 25% of live load. So what we will do, here we will copy this, Control C, then here press enter, then Control V. Here load will be changed to weight. Okay, then here we have provided dead load only. We need to include 25% of live load also. Okay, so on this members 2.22 kilonewton per meter dead load, in similar members we will add 25% of this live. Here it is 3.135 kilonewton per meter. We will calculate 3.135 into 0.25 78375 plus 2.22. So it will be 3.003. We can write here 3.0. There is another way to include dead load and live load in seismic definition. I will show that one in next tutorial. Here I am showing the issues are generated when we go for this next 1.11. This one 1.568 into 25%. this one plus here it is 1.11, 1.11, so it is coming 1.50, so we can type here 1.50. Now we can save the Staad editor. Here we can check whether it is assigned correctly or not. How we can solve it? Go to edit, and here we can see this is coming into distance, not in loading. So what we can do, we can type here minus 3.0 kilonewton per meter, make it 0, change. Okay, here we can edit, can make it 1.5, and make it 0, change. Here edit 0, here minus 2.1, change. Then this one edit, delete this one 1.05, here make it 0, here comes minus, change. Okay, so if we do not check this, then our analysis result will be wrong. Okay, so we have to be careful when we will include dead load and live load in seismic definition from Staad editor. Okay, so this is the number one we wanted to discuss in this tutorial. Now come to number 2. Only one UVC can be solved in a tension compression analysis with a warning that shows if this UVC analysis has tension, compression or repeat load or etc., then each UVC IVC case should be followed by perform analysis. And so how to solve the issue we will see now. Here we can see in the screenshot, we will discuss this issue with the solution. Let's see. Now we will run the analysis. Here we can see 2 error shown. We can view output file. Here we can see only one UVC case can be solved in a tension compression analysis. How this error can be solved? Here is warning related to this error. Here it is showing that we have to use this phrase perform analysis and to do the analysis following one by one load cases defined in UVC or IVC analysis, because there is tension compression definition in the model. Here you can see we have provided tension rod pressing in this model specification, here member in tension. So what we have to do, we have to go to Staad editor. Here define IVC self weight 1, and then we have provided load case 1, 2, 3, 4 for seismic load cases. Here what we will do, we will type perform analysis, then enter change. Okay, this 2 line we will copy, then press enter, paste here, press enter, paste here, press enter, paste here. After the seismic load cases, we have to provide these 2 lines perform analysis change, so that these load cases will be included in the analysis one by one. Now we will save the editor, then close. Now we can run the analysis. Run analysis. Now we can see 0 error and other warnings in the model. Next we will remove this warning in this tutorial. Here the warnings are related to zero stiffness. We will solve this issue also. So this issue we have solved here. Now we will go to here instability at joint. Joint number will be here and here will be direction. Here direction mx. That means the direction or rotation about x-axis. Go to next slide. There are different types of instability we may see. One is local, number two is global. Local instability caused for member truss, member release. Global instability caused for support condition, improper connectivity. So we need to be careful about this issue. Another types of instability occurs for stiffness problem or zero stiffness at a joint. See here, warning for zero stiffness in direction. Here is snapshot. Warning, zero stiffness in direction 5 at joint 69. Here is equation number. This may be due to all members at this joint being released or effectively released in this direction. Here the causes described. From this message, how we can understand in which direction this zero stiffness has occurred. Let's see how we can understand this. Every joint or node has 6 degrees of freedom. 3 translational degree of freedom along 3 global axes and 3 rotational degree of freedom with respect to 3 global axes. In figure we can see translation in one direction. If this node is free to move along this direction, then along this direction there will be degree of freedom number 1. If this node can move along this direction, number 2 direction, then this node will have degree of freedom number 2. Similarly, along this direction it will have degree of freedom number 3. Now, if this node can rotate about the axis 1, then it will have number 4 degree of freedom. If this node can rotate about the axis 2, then this node will have degree of freedom number 5. And similarly, if this node can rotate about the axis 3, then it will have degree of freedom number 6. Number 1, 2, 3, 4, 5, 6. These numbers are shown in the warning. Here we can see the direction 5. That means the rotation about direction 2. In Staad Pro, this direction is along y-axis. So this will be rotation about y-axis. You can see here we can define the degree of freedom as per global axis as below. Translational degree of freedom delta x, delta y, delta z. Here will be z, here will be z. Direction 1 in Staad Pro output report along x-axis. It will be direction 2 along y-axis. Direction 3 along z-axis. Okay. If we see in the warning message the direction 3, then we can understand the zero stiffness has occurred along z-axis for translational degree of freedom. Now for rotational degree of freedom, about x-axis direction is 4, about y-axis direction is 5, about z-axis direction is 6. So if we release a node for all the translational and rotational movement, then a node will have 6 degree of freedom. If we release a node for rotational movement and we fix the node for translational movement, then it will have 3 degree of freedom. We will discuss now. Here if we make a support fixed, then the support node will not be able to move in any direction or rotate about any axis. When we provide this support, fixed support, that means all degrees of freedom are restricted. That means that point or support will not have any degree of freedom. If we make a support pinned, then the support node will not be able to move in any direction but can rotate about all three axes. So 3 degrees of freedom translational will be restricted. That means that joint will have 3 degree of freedom only for rotation. Right? If we provide 100% moment release in all 3 directions for a member end, not support node. This is not for support node. Then that end node will be able to take load and shear from all 3 directions. This means it has stiffness to resist force along 3 directions but will not be able to take moment in any direction. This means it has no stiffness to resist moment or rotation. Now come to this. Instability or zero stiffness condition is related to particular direction in which or about which there is no fixity or rigidity or stiffness. This happens when both end joint of a member is released in a direction. That direction has loading or moment to be carried out. So from this discussion we can understand if there is release in support or any member node, then instability or zero stiffness condition may occur. You can see in different model truss. Open this one. Here we can see a truss structure which is supported with pinned support and having the load along z axis. Okay, and we have assigned these members as truss member. We can see in specification member truss. Here you can see highlight the assigned geometry. Here you can see we have assigned this portion as truss portion. Now here if we run the analysis, we can see warning messages. Here we will see that warning. Before that, if we go for post processing, we can see almost infinite displacement in this structure. This is not acceptable. We have to fix this issue. Now we will see what is the warning it in our Staad output. Here we can see warning in stability at joint 2, direction mx, about, here we can see about x-axis, joint 2 my, joint 3 fx, joint 4 mx, joint 4 my. So 2, 3, 4 number node or joint is under this instability condition. Here if we go to modeling mode, we want to see the nodes. 2, 3, 4. Here, here, and here. Other zero stiffness issue also we have found. Direction 4, 5, 6. 4, 5, 6. It means the joint 3, 6, 7 has zero stiffness against the direction about x-axis, about y-axis, and about z-axis. That means these joints are having moment releases. So we have to solve this issue. Loading along this direction, and as these are our truss members, so member ends will have releases for mx, my, and mz. That means moment or rotation about x, y, and z axis. So for these members there are no resistance against these applied forces, and also here in our support we have released mx, my, mz. That's why it is pinned support. So it also has no resistance against rotation. So to solve this instability and zero stiffness issue, we can change the support condition. Go to support, create, add fixed support, this one, then select the nodes, assign, yes, and from here we will change this truss member into simple member with a specification that will make the simple members equivalent to truss member. So let's see how to do that one. Go to specification, we will delete this specification, delete, okay. We will go to beam definition or beam member specification. Here we will go to release, partial moment release, because if we go for release, that will be 100% release. We will click on MP if we want to release all three rotation or moment about x, y and z axis. Otherwise, if we want to release MPX, MPY, MPZ separately, or only two or only single rotation, then we can click on that specific moment release. Here we will go for this release along about all the axes. So I will click on MP. Here 0 means full moment restrained and 1 for no moment restrained. If we provide 1, then 100% release. If we provide 0.99, then 99% release. That means 1% restraint. This 1% restraint will provide 1% rigidity or 1% stiffness. That will remove the warning 0 stiffness. Okay. So add this one. This will be at start, and for end similarly this one 0.99 add. Okay. If we provide this release for these members, then the simple members will be converted into truss member, but only difference is 1% stiffness. So we can go in this way to solve the issue. Now I will select the members and assign to selected beams, yes. This one also assign to selected beams, yes. Now these members are converted into truss member with 1% stiffness. Okay. Now if we run the analysis, here we can see 0 warning, 0 error. Okay. Here no error and warning generated. So in this way we can solve the issue of instability and zero stiffness. In previous model we can open that one. Now in this model we will check the warnings. Here 0 stiffness in direction 5 at joint 71, 71, 73, 75, 69. These are the nodes or joint which has 0 stiffness along direction 5, that means about y axis. Close this one. Here if we want to see the joint number, click on this node number, apply 69. Here this one 71, 73, 75. So this support or joint, these joints are having 0 stiffness issue, because here we have applied the loading along x direction for wind load. Here you can see wind loading is positive x-axis along and positive and negative x-axis. So these four support are having this issue because here also we have released 3 rotation or 3 moment, and at top of the member also we have released 3 rotation or moment. So both end of a member has been released for moment that will not give any stiffness against rotation. That's why this zero stiffness problem is showing. Here if we see, and another thing, if statics check table in reaction tab of post processing stage shows variation in force moment, then we must have to solve the issue. Otherwise this warning can be ignored. Now we will check statics table. Go to post processing, apply OK, reaction, here statics check result. Okay, here we will see the load for wx minus 7 and 8. Here 7, here difference is also almost 0, as there is no difference for in applied loads and reaction, so this warning can be ignored. Although it can be ignored, we can remove this warning. Now we will see how to remove this warning. Go to modeling. Here both end of these members have been released for 100% moment. So two ways we can follow to remove this warning. Number one is we can provide fixed support at the base of these members, then this warning will be solved. And another way, we can go to specification, click on highlight the member. Here end of these four members mx, my, mz has been released. This release we can change it to partial release. Here if we see, here we have provided 100% release for mx, my, mz, that means rotation about x, y and z axis. So if we change it to partial release, that means 0.99, 99% release, which has 1% restraint condition, that means 1% resistance or stiffness will be there at the end of this member. It will remove zero stiffness warning. First we will see number one method to provide this fixed support, then we will see for partial release. Okay, keep it same like this, 100% release. Go to support, here create fixed support, yes, this one, then select the support joints, assign yes. So one end of these members are having rotational restraint now. Now if we run analysis, here we can see view output file, there will be no warning or errors. Now I will go for second method. Keep this nodes same as they were. Pinned support. Now I will change the specification from 100% moment release to partial moment release. Click on this. Partial MP means about all the x, y and z axis. This will be here 0.99. That means 99% release, 1% restraint, 1% moment will be carried by the end of these members. That 1% stiffness or resistance will remove the warning of zero stiffness. Change. Okay. Now we will run the analysis. Here we can see zero error, zero warning. Okay. So following these two way we can remove this warning. Now as we have discussed about the difference of applied load and reaction load, we will see in that model. Here if we keep same truss members as it was before, go to general, specification, beam, truss, add, assign to selected beam, assign, yes, and delete this releases, partial releases. Now if we run the analysis, go to post processing. Okay. Now go to reaction. Here statics, check result. We can see at load case 2, that means WZ load case, applied load along a Z direction 80 kilonewton, but reaction here it is 10 kilonewton. That means 17 kilonewton difference here. So if this difference we see in the result, then we must have to remove those warnings. Here we can see the warnings, zero stiffness. So earlier we have seen how we have removed this zero stiffness. We can see again that one. Go to modeling, select this members, then general, specification, beam, partial moment release, MP, 99%, add, beam, end, partial moment release 0.99, add. Okay, assign to selected beam, yes, end, assign to selected beam, yes. Then this member truss we will delete. Now we will run the analysis. Zero error, zero warning, that means zero stiffness warning removed. Now go to post processing mode. Okay. Now if we go to reaction tab, here we will see statics, check result. Here our applied load is 18 kilonewton, reaction load is 80 kilonewton. So difference is zero. Our model is perfect for the analysis result. If you find this tutorial is useful or helpful to you, then please like the video and also share the video to your friends and colleagues, and subscribe the channel to get more important tutorials. So thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.